M. Victor Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to DTH channel, lecture 8 of Astronomy and Astrophysics. This lecture is about galaxies. I am going to present this lecture in the following way. Introduction, types of galaxies, Hubble's tuning fork diagram for the classification of galaxies, Milky Way galaxy, our own galaxy, and summary of the discussions we are going to have. Galaxies, as we know, is a collection of stars. There are many galaxies are there in our universe. Galaxies are sprawling systems of dust, gas, dark matter, and anywhere from 1 million to 1 trillion stars that are held together by gravity. You know, all objects in the universe are held together by the gravitational force, gravity, which is a remarkable discovery in humankind. Nearly all large galaxies are thought to also contain supermassive black holes at their centers. Our Milky Way galaxy also spins around Sagittarius A, a supermassive black hole that contains as much mass as 4 million suns. So, such high mass black hole is at the center of our own Milky Way galaxy. The deeper we look into the cosmos, the more galaxies we can see. One 2016 study estimated that the observable universe contains 2 trillion or 2 million galaxies in the universe. Here they are talking about observable universe. You know, there are innumerable non-observable universe are there. So to the humankind, how much part of the universe is observable, that much part contains 2 trillion galaxies. Some of those distant systems are similar to our own Milky Way galaxy, while others are quite different. This is an artist's impression of the black hole Sagittarius A, which is the center of our Milky Way galaxy. So, like Milky Way galaxy, each galaxy or all galaxies have a black hole at its center. This is the image of Andromeda galaxy, which is the closest neighbor to our Milky Way galaxy. This image is made by NASA people. Then this is the image of Milky Way galaxy rises above the Swiss Alps mountain. Milky Way galaxy rises above the Swiss Alps mountain. So from Earth we can see the rise of the galaxy, collection of stars. Now come to the types of galaxies. Astronomers and researchers have classified galaxies into different types. Before the 20th century, we did not know that galaxies other than the Milky Way galaxy existed to the humankind. Earlier, Astronomers had classified them as nebula since they looked like fuzzy clouds. But in 1920s, astronomer Edwin Hubble showed that the Andromeda Nebula was a galaxy in its own right. Andromeda is the closest neighbor to our Milky Way galaxy. Since this Andromeda is so far from us, it takes light years from Andromeda to reach our Earth to take 2.5 million years to bridge the gap. So, the distance of Andromeda from Milky Way galaxy is 2.5 million years. Despite the immense distance, Andromeda is the closest large galaxy to our Milky Way galaxy, and it's bright enough in the night sky that it's visible to the naked eye in the northern hemisphere of the night sky. In 1936, Hubble debuted a way to classify galaxies, grouping them into four main types: spiral galaxies, lenticular galaxies, elliptical galaxies, and irregular galaxies. Before 20th century, we know only our Milky Way galaxy. All other galaxies are termed as nebula by the astronomers. Only in 1936, Hubble gave a classification for the galaxies. More than 2/3 of all observed galaxies are spiral galaxies. A spiral galaxy structure will be like a spinning wheel. This spiral galaxy has a flat spinning disk with a central bulge surrounded by spiral arms. That spinning motion spins at a speed of hundreds of kilometers a second. This speed of spinning may cause matter in the disk of the spiral galaxy to take on a distinctive spiral shape like a cosmic pinwheel. So this is how spiral galaxies could have formed is the view of astronomers. Our Milky Way galaxy, like other spiral galaxies, has a linear starry bar at its center. The disk of stars orbiting the bulge separates into arms that circle the galaxy. In spiral galaxy, the disk of stars orbiting the bulge separates into arms. These spiral arms contain a wealth of gas and dust and younger stars that shine brightly before their quick demise. One astronomical theory suggests that galaxy arms could be the result of density waves traveling through the outer disk. From the center disk, density waves travels to the outer disk so that the spiral galaxy could have been formed. Then collision between galaxies, encounters between galaxies could cause such waves as the mass of the smaller galaxy could affect the structure of larger galaxy as the two combine. You know, galaxies are moving away from each other or moving apart. Innumerable galaxies are there in our universe. These galaxies would have been formed after the Big Bang explosion, which took place some 13.5 billion years ago. So galaxies are formed, those galaxies are moving apart. In its path, some other galaxy encounters, then collision takes place, two galaxies will combine, then shape of one galaxy will change into other. Spiral galaxies are thought to evolve into elliptical galaxies as the spirals get older. So out of the four types of galaxies classified by Hubble, the spiral galaxies are changed into elliptical galaxies as they get older. One of the largest known spiral galaxies is NGC 6872, which is 522,000 light years across from the tips of its outstretched spiral arms. That's about 5 times the size of the Milky Way galaxy. This is the largest known spiral galaxy. This is the figure of this giant NGC 6872 spiral galaxy, which is the largest known spiral galaxies. Elliptical galaxies are shaped, as their name suggests, are generally round but can stretch longer along one axis than along the other, so much so that some take on a cigar-like appearance. Ellipse has 2 axes, a major axis and minor axis. If a galaxy is like ellipse that can stretch longer along one axis and smaller along the another axis. The universe's largest known galaxies, giant elliptical galaxies, can contain up to 1 trillion stars and that span 2 million light years across in size. This is the universe's largest known giant elliptical galaxies. Elliptical galaxies may also be small, in which case they are called dwarf elliptical galaxies. Elliptical galaxies contain many older stars but little dust and other interstellar matter. Stars of the elliptical galaxies orbit the galactic center like those in the disks of spiral galaxies, but they do so in more random directions. Elliptical galaxies can be studied using the galactic coordinate system. In astronomy, 4 different coordinate systems are used to locate the position of the astronomical object with respect to Earth. Those 4 coordinate systems are central coordinate system and galactic coordinate system, ecliptic coordinate system and lunar coordinate system. These are the 4 coordinate system used in astronomy. So, galactic coordinate system can be used to study the galaxies. For new stars are known to form in elliptical galaxies. These few new stars are common in galaxy clusters. Coming to the next type of galaxy, lenticular galaxies. Lenticular galaxies such as the iconic Sambro galaxy sit between the elliptical and spiral galaxies. They are called lenticular because they resemble the shape of the lenses. Like spiral galaxies, lenticular galaxies have a thin rotating disk of stars and a central bulge, but they don't have spiral arms. That is how lenticular galaxy got its name. Like elliptical galaxies, these lenticular galaxies have little dust and interstellar matter, and they seem to form more often in densely populated regions of space. So, this is the picture of galaxies: elliptical galaxy, spiral galaxy, irregular galaxy. Example for elliptical galaxy: ESO 325 G004. Example for the spiral galaxy: M101. Irregular galaxy: NGC 1569. This is a photograph of the types of galaxies. Coming to irregular galaxies. Galaxies that are not spiral, lenticular or elliptical are called irregular galaxies. Irregular galaxies such as the large and small Magellanic clouds that flank our Milky Way appear misshapen and lack a distinct form because they are within the gravitational influence of other galaxies close by. That's why irregular galaxies don't have shape, but the stars are in group. We know galaxies are formed due to the grouping of stars. Large number of stars exist as a group, so that we got galaxy. Here these irregular galaxies don't have shape, but gravitational pull is there among the objects of the galaxy. That's why it exists. They are full of gas and dust. These irregular galaxies are full of gas and dust, which make them great nurseries for forming new stars. This is how irregular galaxies can be learnt. This is the picture of Hubble's tuning fork diagram for the classification of galaxies. The hand of the tuning fork carries the elliptical galaxies, then one wing of the tuning fork carries the spiral galaxies, then other wing carries the barred spiral, then this is the irregular galaxy. So the Hubble classification scheme for galaxies often referred to as tuning fork diagram, because this appears like a tuning fork. Here this elliptical thing is E0 to E7. Then the spiral thing is between S0, SA, SB, SC. Then barred spiral SBA, SBB, SBC. This is how Hubble's tuning fork diagram is used to classify the galaxy according to properties. Elliptical galaxies, which are in hand of the tuning fork. You know, ellipse has two axes, major axis, minor axis. These elliptical galaxies are further classified according to the ellipticity of the galaxy, and Hubble give a formula E is equal to 10 into 1 minus B by A, where A is the semi-major axis and B is the semi-minor axis. Based on the value of this B and A, the galaxy get its ellipticity. Observed values range from E0, which is circular cross section, a spherical galaxy, to E7, the most flattened galaxy. E0 are considered as early type elliptical galaxies, and E7 are the late type elliptical galaxy. This is how Hubble's elliptical formula to learn the ellipticity of the galaxy is used to classify the galaxies from E0 to E7. Coming to the spiral galaxy and barred spiral galaxy. The spiral galaxy and barred spiral galaxies are located in the arms of the tuning fork, as we are seeing in this diagram. Located in the fork of the Hubble's classification diagram, and intermediate between the elliptical and spiral galaxies are SO or SBO galaxies. These galaxies show prominent bulges but no spiral arms. Spiral galaxies are classed from early type to later type according to the ratio of the luminosity of the bulge compared with the disk and the amount of winding of the spiral arms. So S0 to SB0 is classified according to the ratio of the luminosity of the bulge compared with the disk. The type SA, which is early, have prominent bulges. Bulge to disk luminosity ratio is approximately 0.3 for this SA type spiral galaxy. Then tightly wound arms, that bulge to disk luminosity ratio will be approximately 0.6, and the stars in the spiral arms are distributed very smoothly. Then coming to type SC, which is a later spiral galaxy, have the least prominent bulges. Bulge to disk luminosity ratio will be very small, approximately 0.05, and loosely wound arms, pitch angle approximately 0.18, that are resolved into clumps of stars and H2 regions. So the spiral galaxies SA and SC are classified according to the bulge to disk luminosity ratio. So this is the example of M84 and M86 elliptical galaxies or S0 galaxies. So like that, many galaxies are observed by the astronomers in this world. Now coming to barred spiral galaxies. In bars, the spiral arms do not start directly from the bulge, but from an extended bar of stars that passes through the bulge. They share the same range of classification as non-barred spirals from type SBA, which is early type barred spiral galaxy, to SBC, which is later type barred spiral galaxy, according to the prominence of the bulge and the winding of the spiral arms. Irregular galaxies. A later extension to the Hubble classification was the inclusion of irregular galaxies in two classes: irregular galaxies type 1, irregular galaxies type 2. Irregular galaxy type 1 is included irregular galaxies that showed some hint of organized structure, such as the large and small Magellanic clouds, while irregular galaxy 2 were those irregulars that were completely disorganized. This is how Hubble incorporated the irregular galaxies in the classification of the galaxies. Coming to the properties of galaxies, mass of the spiral galaxies will be approximately 10 power 9 to 10 power 12 times the mass of the Sun. And for ellipticals, this mass of the galaxies will be 10 power 5 to 10 power 13 times the mass of the Sun. For irregulars, mass of those galaxies will be 10 power 8 to 10 power 11 times the mass of the Sun. Diameter of the spiral galaxy will be 15 to 150 light years. Elliptical galaxy diameter will be 3 to 700 light years. 3 to 30 light years is the diameter of irregular galaxy. Luminosity of the spiral galaxies will be 10 power 8 to 10 power 11 times the luminosity of Sun. Then elliptical galaxies 10 power 6 to 10 power 11 times the luminosity of Sun. For irregular galaxy, the luminosity will be 10 power 7 to 2 into 10 power 9 times the luminosity of Sun. Population of stars in spiral galaxies will be old and young population of stars will be there. In elliptical galaxies, only old stars will be there. In irregular galaxies, both old and young stars will be there. What are the interstellar matter present in spiral galaxies is gas and dust. In elliptical galaxy, almost no dust will be there, but little gas is there. In irregular galaxy, much gas, some have little dust, some much dust. Then mass to light ratio in the visible part of the spiral galaxy will be 2 to 10. Then elliptical galaxies mass to light ratio will be 10 to 20. Then mass of the irregular galaxy will be 1 to 10. Mass to light ratio for total galaxy 100, for ellipse also elliptical galaxy also it will be 100. Like that, properties of different types of galaxies are studied and listed by the astronomers in our world. Next, our Milky Way galaxy. This is a spiral galaxy which is about 100,000 light years across wide. If you could look down on it from the top, you would see a central bulge surrounded by 4 large spiral arms that warp around it. Unlike a regular spiral, a barred spiral contains a bar across its center region and has 2 major arms in that Milky Way galaxy. Milky Way also contains 2 significant minor arms as well as 2 smaller spurs. One of the spurs, known as the Orion arm, contains the Sun and the solar system in which we are living. The Orion arm is located between 2 major arms, Perseus and Sagittarius. The Milky Way does not sit still, but it constantly rotating. Sun and the solar system also travels with that Milky Way galaxy. The solar system travels at an average speed of 828,000 km per hour. Even at this rapid speed, the solar system would have about 230 million years to travel all the way around the Milky Way. Our galaxy is surrounded by an enormous halo of hot gas that extends for hundreds of thousands of light years. The gas halo is estimated to be as massive as all of the stars in the Milky Way galaxy. Like the galaxy itself, the halo is spinning rapidly. Milky Way contains over 200 billion stars and enough dust and gas to make billion stars more. So Milky Way galaxy is still producing stars. It has enough dust and gas to produce more stars. The solar system lies about 30,000 light years from the galactic center, about 20 light years above the plane of the galaxy. Earth and its neighbors don't orbit within the plane of the galaxy, but are instead tipped by about 63 degrees. More than half the stars found in the Milky Way are older than the 4.5 billion years. Galaxies like ours typically undergo a stellar baby boom, crunching out stars in enormous quantities roughly 10 million years ago. Then the most common stars in the galaxy are red dwarfs, a cool star about 10th the mass of the Sun. Once this Milky Way galaxy was thought unsuitable for potential life-bearing planets because such bodies would have to be too close to meet the criteria. Red dwarfs are now considered potential suspects. This is how the properties of our Milky Way galaxy can be learnt. Coming to the summary of the discussion we had, galaxies are sprawling systems of dust and gas, dark matter, and anywhere from 1 million to 1 trillion stars that are held together by gravity. One 2016 study estimated that observable universe contains 2 trillion or 2 million galaxies. But in 1920s, astronomer Edwin Hubble showed that Andromeda Nebula was a galaxy in its own right. A spiral galaxy has a flat spinning disk with a central bulge surrounded by spiral arms. Elliptical galaxies may also be small, in which cases they are called dwarf elliptical galaxies. Elliptical galaxies contain many older stars, but like dust and other interstellar matter. Galaxies that are not spiral, lenticular or elliptical are called irregular galaxies. Irregular galaxies are classified into two. Milky Way is a barred spiral galaxy about 100,000 light years across. The solar system travels at an average speed of 828,000 km per hour. This is how we can learn things about our galaxy. You can learn more things about galaxy by referring these websites. Thank you.